Okay, so the question is, what's a computer network? I start with a computer. I have, let's say, computer number 1 over here. And computer number 1 wants to talk to computer number 2 over here. Now, originally what they did was they made a cable that just went between the two computers. Look kind of like this. And they hooked the computers up like that. I have computer number 1, computer number 2, and we'll add in computer number 3 here. Each computer is trying to send a message to the other. So if everyone just adds a message on the cable, it says, hey, I've got a message for you. How do you know which computer it's going to? So they had to decide to give computers some kind of code or address, just like your house has an address, to know which computer was getting the message. So in computer terms, they actually took 4 numbers and put them together for computer bytes, and a byte represents a number from 0 to 255. We'll explain why that limit is 255 another time. And they gave each computer a number, and its number is its unique address. These numbers look something like this. The number of this first computer might be 192.168.1.1. Okay, 4 numbers in a row with a dot between them. This one, what these numbers actually represent, the first 3 numbers represent this whole connection, this network. So the second computer here will be 192.168.1.2. And this third one will obviously be number 3. So now what happens, dot 3, is this computer puts a message on this wire, and it says, this message is for dot 3. And he's listening, and if he sees a message for dot 3, he picks it up and listens to it. Okay? And obviously number 2 only listens to messages for 2, and so forth. Now, this little wire that we started with here, little wire, started as a good idea. But what happened is they kept connecting more computers. So here's another computer. Here's another computer. And they came along and they said, well, this is very nice, but this computer right here, he started sending out a bad signal because something broke. So when he started sending out a bad signal, the whole network went down. He's sending out a mess on the cable, a short, an electrical problem. So the whole network dies. So they came along, and the engineers came along, and they said, well, this works good for sending the messages across, but this physical structure is a bad idea. Obviously, if we have the computers working like that, and one computer has a problem, the whole network stops working. They came along, I'll erase this and start over. They came along and said, okay, we're going to create a computer device that we're going to put in the middle. Little computer device here. And we call that little device a hub. And we're going to connect all our computers through the hub. Each one's going to get an individual wired connection. Each one's going to get an individual wire connection. So we have one of our computers here, and this is, like we said before, dot 1. Here's another computer here. It's dot 2. This one over here is dot 3. This one over here is dot 4. So now, if dot 1 sends a message, what happens is the hub gets the message. It says this message is addressed to dot 3, and the hub repeats the message. It sends the message out to everyone. Okay? And it's the same as before. When dot 3 says it sees the messages for him, he listens to it. Everyone's getting the dot 3 message. Only dot 3 is paying attention. Okay? That's basic computer networking. You stick a hub in the middle, you connect your computer connections, and the jacks look like big telephone jacks. And each computer is sending messages to another. Now we add one more fact that's become very common today. This is the way everyone works today. And that is, what if I connect my network to another network? When we connect one network to another, we have a common term for that nowadays. We say we have an internetwork, an internet. Okay? So what happens in this case, we're going to erase this again and start over, is we say that I have my computers here, my 3 computers here, I have my hub, mark this with an H for a hub. I'm going to connect each one of my computers to my hub. This one is .1, .1, this one is .2, this one is .3. Excuse me. And you remember I gave this a silly number, not a silly number, but an actual 4-digit number. I said this network has a number like 192, and I picked this number 192 because this is actually the default number for most hubs and routers. 192.168, and I said .1, and in this case I'm going to say the hub itself has an address. It's called .0. And actually our hub's name is going to change. Instead of being a hub, I'm going to erase our little H there, we're going to call this a router. The router has one special ability that a hub doesn't have. A router, you can connect it to another network. So we have another router over here, which represents another network. We connect router 1 to router 2, and the difference in this case is this network is, the hub is switched to a router, is 192.210.1.0. Okay? And it has some computers connected to it, or maybe it's connected to another router. It doesn't matter. And so now, what this router says is, if computer .1 over here is sending a message to .2, the router says, oh, this message that I just received is supposed to go to .2. And so it gives it over to .2, and .2 sees this message is for me, and it uses it. But if the router receives a message, and that message says on it, I'm for 192.210, the router goes, oh, this is not for my network. It doesn't belong to any of my computers, because one of the first three numbers was different. So because one of the first 3 numbers is different, I'm going to throw it over to the other router. And the other router does the same thing. He looks over and he says, oh, this message is for 192.210, that's for me, and now I'm going to send it to the right computer on my network. Or maybe it's not for him at all. Maybe he's connected to another router over here, and this router's address is 225.1.5.7, and this message was sent to that address. This message was sent to 225. So the router sent it over here, and this router did the same job. He said, oh look, this starts with 225. I'm 192.210. I'm not 225. I'm going to send it out. And that's basically how the internet works. Now, we were talking about IP addresses. We get these 4-number addresses. As we said, the address for your local network is usually 192.168.1.1. Sometimes it's .0.1, sometimes it's .2.1. And that's very nice, but I don't want to go to 192.168.1.1. I want to go to Facebook.com. Now, we did a little test here, and we did a little lookup, and we found out that Facebook.com is actually 66.220.149.88, and you could try and memorize that, but that would be pretty ridiculous, right? So instead, somebody came up with a system, and he called it the DNS system, and it stands for the Domain Name System. And what the Domain Name System does is it just puts a name with a number. So it says 66.220.149.88 equals Facebook.com. And that's the way I was able to look up the address of Facebook. I went to the domain name system and I said, what is Facebook.com? And it looked it up for me. So we don't have to remember what's Facebook.com. We just put it in. So what happens when we go in our browser and we put in http://facebook.com is it goes to the domain name system and it asks the domain name system, what is the number for Facebook.com? It returns back 66.220.149.88. And then it uses that to tell the network where it's trying to go. The network sends the message to the router sends the message. It says that's not on my network. It sends the message out on the internet. And what happens is actually, and there's actually a row of routers on the internet that all pass the message along. Okay. When we put in that we want to access Facebook.com, the browser sends a message out to what's called the domain name system. And it says, what's Facebook.com's number? It comes back and says, it's 66.220, blah, blah, blah. Right? And so now the computer says, okay, so please, I want to send a message to 66.220.149.88. And it sends that message out on the local network. As we discussed before, the router sees that message and it says, hey, I'm 192.168.1, not 66.220.149. So I'm going to take that message and I'm going to send it out to the next router, out the WAN connection, the Wide Area Network connection. And what happens is there's another router there and it gets the message and it says, well, am I 66.220.149? I'm not. So I'm going to send it to the next router on my network. And then, basically, each one of these routers, starting with your router, right here, he says this message isn't for me, he sends it to the next router, looking at that number, that router says it's not for me, he sends it to the next router, he says it's not for me, he sends it to the next router, and before your message gets to Facebook, it's going across the internet actually means sending from router to router to router to router, and just to find out, just because it's kind of interesting, let's do a little command here to find out what it takes to get to Facebook.com. We're going to use a command called traceroute. On Windows, it's traceRT. And we'll put in that number, 66.220.149.88. And we're going to get a list of routers that our message is going through to get where it's going. Each one's going to take about 10 seconds to find. And by the time we're done, there'll probably be a list of at least 5. More likely, because we happen to be recording this in Israel, and that's pretty far away from the U.S. as far as routers are concerned. Pretty far is not distance, but the number of routers it has to go through. We're probably about 16 routers away. So each one of these lines that's going to come up is going to represent a router. Sometimes the routers won't tell us their number, so it will say request timed out. Other times they'll come back and tell us their number, depending on how they're configured. So eventually we're going to get to another router here, which is that 66.220. blah, 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 blah. And he is Facebook.com. And you can say, okay, I have a computer connected to me, which is Facebook server. And therefore, it's going to send the message over to Facebook server. He's going to give a response. And that response is going to come all the way back the same path.